Hi guys, my name is Karthik and I am from easyautomation.com and welcome to an all new video series from Easy Automation on a new type of series that we have not discussed in Easy Automation ever. So this video series, I'm going to call this as Weekends video series, where we are going to talk about a specific technology in much greater detail, not in many different parts, but we are going to be talking about the whole technology in one single video. So the length of this video is going to be much longer than any videos that I have released in Easy Automation, at least except the webinars. But this video is going to be more like a webinar, but it is not a webinar itself. Rather, we are going to talk about a technology, and in this case, we are going to talk about weekends in Docker, starting from the installation through all the way to the advanced concept. So this is going to be something which is like an issue addressed by the community, asking why that I'm releasing so many video parts for a specific technology and they have to wait for a longer time period before the complete video series is fully complete. So these problems are addressed in this particular series, where we are going to talk about a specific technology starting from the basic all the way through, the advanced concept of a particular technology. And in this first ever videos of this weekend series, we are going to talk about weekend with Docker. All right, so let's get started. So the agenda of the weekends with Docker is going to look something like this. As you can see, we are going to start with the introduction to Docker, and then we're going to understand the basics of Docker, like why Docker and what is the purpose of Docker. And we're going to understand the Docker for Linux and Docker for Windows. And there is a preview new version. We're going to talk about that as well. And then we're going to talk about the installing and setting stage ready for Docker and pulling the first Docker image, running the Docker image, understanding Docker volumes, and even exploring the Docker volume right inside a container, and then creating and running our own Docker images for .NET Core application, like a single stage Docker file. And then we're going to use tools for creating the Docker files. There are many different tools available, and we're going to talk about that. And then we're going to create and run our own Docker image for .NET Core app, but in this time with a multi-stage Docker file. And finally, we are going to do a complete conclusion of whatever that we have discussed. So you can see that this kind of video I have released before in many different parts, but today we are going to talk all of these in just one single video. So we have many things to talk about. So let's quickly jump into the introduction to Docker. But before jumping into the actual Docker itself, I'm going to show you some of the videos that I have already released in our Easy Automation, something like understanding the ABC of Docker. I released on December 2016. And then I also talked about Selenium Grid with Docker on August 26, and understanding Docker for Windows on February 2017, or maybe it started with all the way from 2016 again, and I have released all these videos basically. So if you feel that you want to go even more deeper or even more nitty-gritty details on the Docker, you can please go ahead and watch these video series, which has many details that we will not be covering in the first video because this video is going to be very, very bigger. So please go ahead and watch there for a complete understanding. And great man said that an investment in knowledge pays the best interest, which is really cool. The reason being, we have already talked about Docker in many different videos, but those ideas or the real stepping stones for the newer versions of Docker and Kubernetes or whatever services that's coming out in the technology areas right now, and it really pays off with even more deeper or greater understanding of how these new technologies are really changing the shape of the market. And this also helps us not to just stay in the legacy system, rather it helps us to build our own knowledge in the newer technology system as well. Well, as that said, we're going to talk about first the introduction to Docker. So what is this Docker? Well, in a nutshell, it's a software containerization platform, and it provides abstraction of operating system level virtualization. So you can see this is actually a deeper concept. Basically, I have put them in one line, but it's even more deeper. It says that it's a software containerization platform. So basically in Docker world, everything is containers. So you can see me telling about this Docker containers and container images and pulling the containers and pushing the containers. Everything is containers. So basically in Docker, every single thing is actually a container, and container is what that we'll be talking about in this whole Docker video itself. So in a high level, the Docker container actually contains like an operating system, a software that you build, and the dependencies to run the software, environment variables, volumes, and you name it. So as you can see, assume that this is a Docker container, then it is going to have a software that you're going to work with. And because the software requires an operating system to work, it also will have an operating system. And because an operating system and the software requires some sort of data to store, it also has a data or volumes to be mapped within it. And then it will have some environment variables and will have some dependency softwares to run to make the whole container up and running. So this is really, really cool. So basically we are going to be layering all those installation in multiple different containers, and we'll also mix and match the container to make an actual container. So don't worry about all these complex jargons that I'm talking about yet. Just see in a high level that this Docker basically contains an operating system, a software that you run, dependencies to run a software, environment variables, volumes, and much more. So what is the difference between the virtual machine and container? Because I said it's a software containerized virtualization platform. So what is the difference between the actual virtual machine and the container? Because it sounds like a virtual machine. Well, the virtual machine, as you can see, it will have an infrastructure, which is nothing but your physical machine, or it can be a server or whatever you name it. And then it's going to have a host operating system, which can be a Windows, Mac, or Linux operating system. And because you're going to run a virtual machine, it requires a hypervisor. And that's what is this one. And on the top of hypervisor, you will have a guest operating system, its binaries and libraries to run the application, just nothing but the dependencies. And then you will have an actual application. And similarly, if you're going to create one more virtual machine, then you will have one more guest operating system, its dependencies, and the application to execute. So you can see that the guest operating system, if its size is like 10 GB, then you're going to have a 10 GB guest operating system in here. Maybe it's Windows 10 operating system. And then if you're going to have a Linux operating system as the guest operating system, then you're going to have a separate 20 GB of space for that operating system. And then you're going to build on the top of it. So virtual machines are really, really heavy. The reason being you're going to have a separate operating system for a specific application. So let's say for your organization, you're going to have an application which is going to consume many different services or many different microservices, and which is going to run in a multiple different virtual environment. And if you're going to create multiple different guest operating system for each and every component of your application, then the application hosting is going to cost you so much, because that's what the Azure or AWS or Google Cloud are making the money basically. So they don't even recommend basically to have them all in a different operating system like a virtual machine. Rather, they start using what is called as containers and Kubernetes. So that's what this virtual machine is all about. And let's talk about the containers. As you can see in the containers, it will have the same infrastructure and it will have the same host operating system, but just that this time it will not have the hypervisor or guest operating systems. Rather, it will have something called as a container daemon. And then this container daemon is the one which is going to be responsible for running all the containers that I was talking about. And this containers will then have its own binaries, libraries, and application. But as you can see, these are going to be running on a same container daemon, just that these libraries and binaries are going to be running as a layer so that you don't really fill up with a lot of different spaces within your machines or any hosting provider. So that's the major difference between virtual machine and the container itself. Well, how did this Docker actually achieve this container concept? It was really made possible with the help of Alexies or Linux containers, where Alexies are user space interface for Linux kernel containment, which makes it possible to run multiple isolated Linux containers on one control host, which is nothing but the Alexi host. And Linux container serves as a lightweight alternative to virtual machine as they don't require the hypervisors like VirtualBox or KVM or Zen, something like that. So that's the real power of Docker itself, and they really use the power of Alexies to achieve that. I'm not really going to talk about the LXC a lot because that's going to be a vast concept. So this is what it is, makes the whole magic happen behind the scene. Well, as that said, there are 3 different ways that you can run a Docker container itself. One is with Docker for Linux, and the next one is Docker for Windows, and next one is just a hybrid of both of them. Well, it's going to be in preview right now. It is not released yet, but it's pretty much coming soon, and Microsoft is making so much of effort to make this happen. So the first one is nothing but the Docker for Linux. As you can see, if you install a Docker right now by downloading it, it is going to run a Docker for Linux by default, and it's going to run a operating system of Linux in here. So you can see that I right now have an operating system of Linux in here, and the architecture is x86 and 64, and you can see the number of containers running and how many containers running, how many of them are stopped, and how many images I have downloaded and stuff. So these are all running based on the Linux operating system within my Windows machine. So my host machine is Windows, but still it is running within a virtual machine of Linux. And then come the Docker for Windows. While Microsoft started seeing that the Docker is kind of getting very, very popular in 2016, and Microsoft was also working behind the scene to work with the same kind of concept, and they started supporting Docker for Windows from Windows Server 2016 and from Windows 10 anniversary update. So you can see in Docker for Windows, we now have the same kind of containers and how many of them are running and stuff, but just that this time the operating system is actually of Windows, and you can see in my case it shows the Windows 10 Pro version 1909, which is the November edition of 2019. So it's all latest, and it is currently running in my machine right now, and you can see that it's pretty much exactly like how you can see in Linux version, but just that the operating system is completely different this time. And then the LCOW, or Linux Container on Windows platform. So this is a pretty new concept which is going to rock the market right now. So you can run both the Docker container and the Windows container same time, which is pretty cool. So you can run them both side by side, and it's going to look something like this. As you can see, this time it shows you a LCOW for Linux and for the Windows filter as Windows as a storage driver, and you can see there are 2 versions right now. But it still shows you the OS type as Windows. The reason being the isolation is Hyper-V this time, which means it is going to run the Linux in an hypervisor, which is nothing but an Hyper-V hypervisor, and it's going to run both Linux and Windows same time, so you can work on both these images same time. You'll probably understand what I really mean in here in a couple of minutes. So this is the basic difference between Docker for Linux, Windows, and LCOW. So let's quickly see all these discussion in action and understand how things work, because we're going to talk about the installation and start to work with the Docker itself. I'm not going to really waste so much of time in here. Rather, we're going to see everything in practical manner. And before that, you can see that this particular presentation is kind of very, very flashy and pretty awesome. The reason being, this is all coming from the Slide Carnival website. I have downloaded it, and they asked me to give me the credit, which is really, really worth it, because this slide is pretty awesome and I really give credit to them. I'm also going to put this particular presentation's detail in a link below so you can also download and start using it. Well, as that, I'm going to flip to my Windows 10 operating system, and I'm going to start installing the Docker. All right, so now I'm in my Windows 10 operating system, and I'm going to start installing the Docker within my machine. So the first thing I'm going to do is I'm going to open the browser, and I'm going to navigate all the way to the Docker, and you can see that I get this docker.com website. And all the installation right now happens from hub.docker.com. And then if you just go to the products, you can see that we now have something called as a Docker desktop, Docker container runtime, and Kubernetes. So I'm just going to select the Docker desktop, and then I'm going to download the desktop for Windows or Mac. So my machine is going to be Windows. So I'm going to download that. So you can see that it's going to show you what you're going to download. So you can download this and start installing it. I have already downloaded that at least just to save some time. So I'm just going to open the Docker installation. And you can see I have two versions of Docker. One is the Edge version, which is nothing but the preview or experimental version. Another one is like a stable version. So I'm just going to install the stable version and I will show you how it actually looks like. All right, so the installation has started and it says that add shortcut to desktop and use Windows container instead of the Linux container. So I'm just going to use the default option by unchecking this checkbox, and I'm going to install it for now and we'll see how it actually works. And then we'll switch to the Windows container and I will show you the major difference between the Windows container and the Linux container that we actually discussed in the slide. So I'll be back with all the installation is fully done and we'll discuss how things goes. All right, the installation is done. So I'm just gonna close this window and I'm just gonna see there is something called as a Docker desktop. So I'm just gonna open that. And once I open that, you can see that it starts the Docker desktop in my machine. So it will take a couple of minutes to start because this is gonna basically run a full-blown container within my machine. So if I just open my hypervisor or Hyper-V manager, you can see that I now have what is called as a Docker desktop VM. So this Docker desktop VM is something which I told you that within the Docker for Linux actually runs this particular stuff. So you can see that currently it is starting and it's also up and running, which is actually happening because our Docker would have currently up and running. So you can see that it is still starting and the Docker is now up and running over there. Now I can do a lot of things here. So this is the virtual machine, guys. This is the one which I was talking about. This is the hypervisor within my Windows and it is running Hyper-V manager. And it's actually running the Moby Linux for me. So this is the Linux operating system which is running within my Windows 10 operating system. So once the Docker is started, this particular virtual machine was automatically installed and it is up and running, and now it is also started. So you can see that it says that the Docker is up and running right now and you are currently logged in as execute automation, which is pretty cool. We took the catch and now the Docker is installed. So now if I see about Docker desktop, it says this is the stable version and this is the engine being used as of date, which is pretty recent. I've downloaded only today. And you can see that it has some setting and there is something called a switch to Windows container. We'll talk about this in a couple of minutes, but now you can see that we have a very interesting settings in here. Within the setting, the most important thing is the shared drive, networks, you can see the subnets, and then is the daemons. So you can see within this daemon, it shows you the basic configuration over here and the experimental is false. So if you want to turn on some of the experimental features which is about to be released in the market, you can also turn that on by setting this experimental to be true. And then you can do a lot of awesome feature, which we'll be talking about that in a couple of minutes. But yes, these are something that you can see in here. And the Kubernetes, we have already discussed about that in our exit automation channel. You can also enable that and start working with it. But as of now, we're not really going to talk about Kubernetes. We'll create a separate video on weekend with Kubernetes or something like that. So I'm just going to close this setting and then I'm going to start to play around with the Docker as mentioned in the installation part. So I'm just going to open my PowerShell and I'm going to run this in administrator mode. There you go. You can see that the PowerShell also tells me that there is a new cross-platform PowerShell available. Don't worry about it. Just going to see what the Docker commands are going to look like. So the first basic Docker command that I'm going to do is the Docker info. So once I do this, you can see it now tells me how many container I got, how many of them are running, how many of them are stopped, and what is the operating system currently running. You know me that I am running Windows 10 operating system, but it says the OS type at Linux. It says because it's actually running in a Docker desktop application and it is running on a virtualized Linux operating system running within my Hyper-V manager. So you know all of these things, so which means you also know that we are running a Docker for Linux this time. So as that said, I'm just going to start typing the Docker images. So once I see this, you can see that I don't really have any image. The reason being this is a fresh installation. So Docker runs a container based on the images. So basically you need to have an image. So you can see that even right now within my Hyper-V virtual machine manager, I have many different images installed, and all these images is what gonna run within my Hyper-V manager. And in this case, in Docker, we should have an image, and only those images runs and what we call them as containers. So we need to download some of the image to basically execute. And in our case, we are going to pull a very, very useful testing based software, which is nothing but Jenkins. So for downloading that, I'm actually going to go to the hub.docker.com Jenkins. So this hub.docker.com is something you need to basically sign in to the Docker Hub, and only then you can actually download that. If not, you cannot install that. So because as you see within my Docker, I have signed in as Exit Automation based on the Docker Hub username and password. So that's exactly what being used in the hub.docker.com as well. So I'm just going to copy this. You can see that there is a command called docker pull of Jenkins. That's it. This is the one thing that you need to do to pull the image within your machine or within your Docker. So I'm just going to say docker pull of Jenkins. And once I do that, you can see that it is going to start pulling the whole Jenkins for me. But well, you can see that why is this Jenkins been so much of size? Because you know that the Jenkins software is less than 70 MB or something like that. But you can see the size is actually much, much bigger than actual Jenkins itself. The reason being, as I told you, the Docker container not only contains the software that you're pulling, which is nothing but the Jenkins, rather it's also going to host a complete operating system if it doesn't find one. And then it's going to pull all the dependencies, because in Jenkins, as you know, for running the Jenkins, you need a Java, and you also require a JDK or something like that. And also it requires environment variables and ports to be exposed and stuff. So all of these dependencies are now being downloaded, and they are extracted, and they are then pulled in as an image within your local Docker's storage. So you can see that everything is being downloaded, and it's going to be available as an Docker image for you. While it is downloading, I'll also show you how this particular image is going to look like. So you can see that it shows you what is this particular image is going to contain, how you can run this particular image. So it says that the Docker run of -p 8080 -p something like that, and Jenkins will actually run this particular Jenkins. So what is this particular command basically doing? So this Docker run -p 8080 8080 -p 50,000 50,000 of Jenkins basically says that Docker run this particular Jenkins for me on the port number exposed for my host operating system in 8080, and also from the container port of 8080, where also expose me the slave agents port of 50,000 in my host operating system of 50,000 port, so that I can start using this particular container within my local machine and see how it works. So basically you're going to say Docker run the Jenkins for me and expose its port for my host operating system, so that I can then access the Jenkins which is actually running within the container. So because, as you know, that the container is an virtual machine, and you need to somehow get access to the application which is running within that particular container. So in order for that to be accessed, you need to somehow expose the port so that you can start using it. So this particular 8080 says that expose me the internal port 8080 to the external host machine of 8080. Similarly, expose me the internal 50,000 to the host machine of 50,000 port number. So this is what this particular line actually says. And if you want to store your data or the volume of this particular Jenkins, you can also use the same number of command, just that there is an -v which says the volume that you need to actually map within your home location with this particular Jenkins own container location. So we will talk about this volumes and stuff later in this video, but as of now, you can see that this is how the Docker can be executed. So I'm just going to copy this particular command, and I hope this particular Jenkins should have downloaded. And as you can see that the Jenkins image is currently downloaded. And now if I do a Docker images once again, you can see that I have actually downloaded the latest version of Jenkins, which is created kind of 16 months ago. So basically, even though you have downloaded the images today, right now, the image would have been created by the Jenkins team like 16 months before. So you should probably download the latest version based on the tags. Again, guys, tags are something which I have not talked yet, but yes, you can see there is something called as tags, which you can basically use to download the latest versions and things of that nature. So now that we have to execute this particular image and see how it basically works. So in order to execute this particular image as a container, or in order to run this image as a container, you need to run this particular command that we just copied. So, oops, I'm just gonna copy this guy once again. I'm gonna paste it over here. I'm gonna hit enter. So once I do that, you can see many things are actually happening. So it is now going to start the Jenkins. It's gonna set the Jenkins home for you. And also it gives you the password which is required for the Jenkins first time login and stuff, and everything is available right now. And this information is actually coming as a log value for you in here. So now you can directly go to your local machine, and as you know that the port number exposed for running this particular Jenkins within your host machine is 8080. So once I hit enter, you can see that there you go. You now have a Jenkins for you, which is pretty awesome. So you did installed a Jenkins not even within your local machine, rather in a container in just a couple of seconds, just that the download time takes some time, and then your Jenkins is right now available for you to start using it. And it asks you to enter the password in here to start working with it, and we know that we have a password which is somewhere sitting in a long list of this particular log file. So now that we have talked about how this particular Jenkins is actually sitting within my machine, how can I actually see what's running within my container? So this is what we're going to be discussing next. But before that, I'm also going to show you some other basic commands. So for doing that, I'm going to open one more PowerShell command so that I can just retain that particular window there. And in here, now that we saw two commands, or maybe three commands, which is docker info, docker images, and we also saw the docker pull command. The next command is, what is the container being running? How can I actually see that? So for seeing that, you actually need to do docker ps. So this will show you the actual container running within your machine. So you can see we now have an option called as a container ID, and it shows you the image, and it also gives a name, and it is created like 2 minutes ago. So which is running up and running in 2 minutes before, and it is running in the port number 8080, which is pretty cool. And now if you want to stop this particular Docker image, you can do that, or if you want to restart this particular, you can do that as well. But even before stopping it, I'm actually going to show you how to get into the Docker and access those particular files. So for doing that, I'm going to call one more command this time, just nothing but docker exec. So this is an exec command which is going to execute the command within the container, which is pretty awesome, right? So now you're going inside the container. And also I'm going to use in conjunction to exec an it command. So it's an interactive command which basically keeps my session interactive so that you can see the console output coming in within this particular blue window, which is nothing but my PowerShell window. And I'm gonna access the container, so I require this container ID. Just gonna copy that, I'll paste it over here, and then I'm gonna call the application which I can really use. So basically, as we know that this container is actually a Linux-based container, I can just call a bash, hit enter. There you go. You can see that we are now within the bash, guys. I can do an ls here to see what are the files sitting within that particular container. And we also know that all our secret magical keys are actually sitting within the var folders of Jenkins home. So I can just do /var ls, and we have something called a Jenkins home. So I'm just gonna call Jenkins underscore home. Oops. And then I can do an ls. So you can see I get inside in here, and now I can see there is a folder called a secrets. So I can just go through the secrets, and if I do an ls, you can see now I get this initial admin password. So I can just do a cat of initial admin password, and I will get the secret key, which is something I really require to run my Jenkins itself. So I can now paste this, and if I hit continue, you can see that the installation begins. So this is how we can actually install a Jenkins within a container, and you can see all these magical things are happening within the container. And you may be asking, how is this command I can basically remember this, because it seems like within going inside this particular Docker actually requires some knowledge for parsing into it. Is there a way that I can see this in GUI based option? Well, of course, yes. Visual Studio 2019 has this option, and even Visual Studio Code released an awesome way of actually connecting with the remote machine using a plugin called as Remote Explorer. So you can actually go to the extensions and you can search for remote, and you will end up with the remote containers, remote SSH, and many different things. So basically, remote development, as you can see in here, is a preview based version which actually helps you connect with many different options. So I have already installed the remote containers and stuff within my Visual Studio Code IDE. So I can just select this guy, and it says that connect to a host, or connect to a container, or folder within a container, or attach to a running container. So if I click that, you can see that it says amazing Ganguly. So basically this amazing Ganguly is nothing but our container which is currently running. So maybe I can just do an exit, and I just came out of the bash. So I can just clear this guy, and I can just do a docker ps-a, and it shows you amazing Ganguly in here. So this amazing Ganguly is nothing but the one that you just saw. So attached to a running container, and shows you amazing Ganguly. So if I select this, you can see it opens up a remote connectivity happening with my container images, which is actually running within my container, which is pretty awesome, guys. Everything is happening magically, and this is a new feature introduced by Microsoft just recently, and you can see that it is still in preview stage. So it takes some time. In the meantime, you can also see what's really happening behind the scene magically. So if I just expand this a little bit, you can see it's connecting to the Visual Studio Code server, and then it's connecting to the container, and the new connection has been established, and the amazing Ganguly is now attached. And now if I go to the folder explorer, once I connect it, you can see it actually went to the Jenkins home, guys. Pretty awesome. And now I can directly do the same thing that we just did in the command prompt by going to the secrets folder and hit OK. Now you can see that it's going to open all the files within the secrets folder we just saw on the command line, and also brings me my initial admin password. There you go. You get the same initial admin password that we saw on the command line there, which is pretty awesome. So you can do these kinds of stuff magically as well. So you can connect to the remote container, you can connect to the remote host with SSH and all those stuff with this kind of tooling. So that's what I said. We're going to work with the container connectivity toolings as well. So this is the power of it. There are so many different features available. Basically, you can edit the code directly within, which is deployed within the container, and then you can play around with it, which takes so much of time basically in early days before releasing these kinds of plugin. But now everything has been simplified by Microsoft, and thanks to Microsoft team for doing these kinds of amazing job. Well, as I said, we have seen how to work with the Docker image by pulling it, starting it, and seeing the process being running, and how to connect the container images, and even how to play around with those files and stuff. Now that I'm going to stop the container. So in order to stop the container, simple command, docker stop and the container ID. So I can just copy and paste this guy, stop this guy in here, and now that the Docker container is being stopped. So if I do a PS, you can see it is not there, and our Visual Studio is now complaining that it couldn't able to connect it. The reason being the container is now dead, guys. So I'm just going to stop this one. And now if I just do a docker ps hyphen -a, you still see this particular container ID, but just that the status is currently being exited. So you can even remove this by doing the docker rm command to do that. But you can still see if I do a docker images, I still will have this particular image there, but just that only we have stopped the docker container running within this particular docker. So these are the things that you need to know about the Docker for Linux. The next option that we'll be discussing is going to be the Docker for Windows. For Docker for Windows, all I have to do is you need to switch to the Docker container. So for doing that, I'm going to select this particular Docker whale icon there, and then I'm going to switch to the Windows container. So once I select this switch to Windows container, it's going to tell me that you're about to switch to the Windows container. Existing container will continue to run. This is nothing but our Jenkins, which was running before, but currently it's been stopped. But you will no longer be able to manage them until you switch back to the Linux container, or no data will be lost otherwise. So I'm just going to switch right now. So it says that the Docker desktop is switching to the Windows world of containers, which is something I told you that it was introduced in Windows Server 2016 and also from Windows 10 Anniversary Edition. So now if I go to the Docker images, you can see that I don't have any images in here. The reason being that image that you see in here is actually for Docker for Linux, but this one is now in Windows operating system, so you basically will never ever see any of these images. So you can see Docker info this time. You can see the host operating system type is Windows, and the operating system itself is Windows 10 Pro. So it is not Docker desktop this time, rather it is actually Windows 10 Pro version 1909, and the default isolation is Hyper-V. So you will never see any of these new virtual machine running in here because we are running a Windows 10 operating system, so you don't really require any hypervisor there. Right, so as that said, now I'm going to work with a Windows based container. So where should I go? So now if I go to this particular hub.docker.com once again, and I'm going to search for what is called as a Microsoft. And you can see that Microsoft actually has many different containers, guys. Even Microsoft itself will have something called as a Microsoft's own SQL Server, .NET Core, Nano servers, and Windows 10 full-blown, and .NET Windows Server. Everything is available. And the one which I'm going to run this time is going to be the Nano server. So once I hit this, you can see that it brings me up the Nano server. So this is a stripped down version of the actual Windows server itself, and you can see that it is in 1909, which is the latest version of my Windows. So I'm going to pull this, and then I'm going to show you how it's going to look like. So as I said to you before, this is the command that I need to do: docker pull of this particular container registry. So I'm saying the new word in here, container registry. Basically, this is the registry where this particular server's image is being residing. So now if I just do a docker pull of mcr.microsoft.com, you can see that it's currently pulling from Windows of the Nano server. For sure, it's going to take so much of time. I guess the size is around 250 MB or maybe 300 MB. So this is how it's going to download this particular image. So you can see this is basically a Windows container, and you can see the architecture itself never ever says anything close to Linux in here. The reason being, this is a Windows container, guys. So it's taking some time in there. I think it's retrying in 1 second, but it should be done in a couple of seconds. All right, as you can see that the newer version of this particular image has been downloaded, which is pretty awesome. So now if I just do a docker images, you can see that I will now have a docker image running with a Nano server. So because this is a Nano server, or a completely stripped down version of a Windows server itself, I can now run this particular Nano server as well. So instead of this pull, I can just do a run command as we discussed before, and then we can run a application. So basically, you remember in our Jenkins world, we use the bash, and in Windows world, we use something called as a command. So once I execute this, you can see that it is now actually booting that particular server behind the scene. And you can see that nothing is something we can visibly see that. And now you can see that Windows Nano server is actually up and running. And my machine just got stopped because of some reason. I just rebooted my machine and I'm actually back with the same place. So what we were discussing is actually doing this Docker run Microsoft this particular Nano image, and then we're doing a command. So once I do this particular command, you can see that we got this particular option. So the reason what it shows in here, it came a C colon, and then again it shows me a PS of C colon of slash, which means it actually came back to my local machine in here. So if I just do a dir, this particular directory is nothing but my local machine directory, guys. It's nothing to do with the container image itself. Even though the container is actually up and running, you can see that it exited 3 times. It didn't even execute it. So what it says basically is we are going to run, we need to somehow run this guy interactive mode. So if you remember, in order to run this in interactive mode, we need to do what is called as an IT, as we did in the Docker bash command. So I'm just going to do an IT in here, and once I hit enter, you can now see that we have logged in within a different command prompt altogether, which is nothing but the Windows Nano servers command prompt. So now if I just do a dir, you can see that it shows me something different. This time it's not the one which we actually are seeing. So if I just do a license.txt, so it doesn't really have a notepad as well. Maybe I don't really have any command. So maybe if I just do a cd of Windows, and if I do a dir, it shows me all these options. So it's a very, very stripped down version, guys. You will not see all the options that you can really see in your Windows 10 operating system. But yes, you are now within the Nano servers folder location. And this is what is the Windows container itself. So now you would have understood that this particular container is completely different from the Linux world of container that we were talking about. So if I want to exit out from this particular container, all I have to do is I just need to do a close. Or even before that, what if I try connecting with this particular container from my Visual Studio Code? So I just do a Windows Shift P, Control Shift P, and then attach to running container, and you can see agitated Edison. So it's just connecting to that, and it's connecting to the server. Oops, it got some error. Let me try again over here. And it's again getting disconnected. So I have seen this behavior before, that every time while I try to connect to a Windows container, this particular Visual Studio Code somehow throws me an error. It may be an intentional stuff, maybe not, or maybe it's still in development or something like that, which I'm not pretty sure about that, so I cannot tell any reason for that. But it says that the file system operation against running Hyper-V containers are not supported, which is kind of crazy. I don't know why. It should have worked, but somehow it is not working, connecting to a container running in a Windows operating system. So now I'm just gonna say maybe exit. So I just came out of the C colon, and I can now see my command prompt is sitting under PS of C colon, is nothing but my local machine. So now if I just do a docker ps-a, everything is up and running in here. I can now do a docker images to see what's my image running. And now I'm going to do one more thing here. So I'm just gonna switch to Linux container. Just gonna switch in there. So once I switch to the Linux container, as you know, we will never ever see the Nano server image once again. So if I just do a docker images, you can see now we see the Jenkins image, rather Nano server image. And now the next part comes in. What is this LCOW, or Linux container on Windows? So this LCOW is an experimental feature, as I told you before. All you're gonna do is you're gonna go to the settings and go to the daemon, and then you need to turn on the experimental feature. And then once experimental is started, you need to specify the platform as true, and then you need to start running it. And again, guys, those things are kind of still in preview stage. You don't really require to see that demo in my machine as of now. I've already tried that it is running without any problem in my machine, but just that it is still not mature enough to be displayed. But for the basic things, I guess you know now that there is something called as Docker for Linux, Docker for Windows, and an upcoming side-by-side execution of both these containers same time. Because at the moment, in order to run any of these containers, we have to switch to those two versions. But with the Linux container on Windows option, you can run both these images side by side without any problem. And that's the whole intention of Microsoft developing this option. Pretty awesome. So the next advanced option is to work with the coding itself. So basically we're gonna write some code in Visual Studio .NET Core, and then we're gonna run that particular code within the .NET Core code, but that's kind of little more advanced than what we are discussing in this particular video. So I would probably stop this video over here, and I'm going to create one more video. And again, guys, that video is going to be very, very longer than what you're seeing in this one. And we will discuss about the coding part in that video. So once again, thank you very much for watching this video, and stay tuned for our next video. Thank you.